In this example, we're asked to make a conjecture about the difference between consecutive perfect squares. Now, a conjecture is when we notice a pattern and we can say something about it. So we can take a look at what we have, what we can see, and we can say and make a statement about it. It might not be proven, it might not be provable. Now when we look at this question, it also says use inductive reasoning. So inductive reasoning, we're finding a pattern. So in this example, what we're starting with is looking at the shapes. So we have perfect squares. So a perfect square is simply in this case, we have a 3 by 3 square and a 2 by 2 square. So the number of squares you have in a 3 by 3 is 9, and the number of squares you have in a 4 by 4 is 4, or a 2 by 2 is 4. And when you subtract those, you get 5. So there's 5 tiles left. So if we go a 4 and a 3, so again, this is consecutive squares. So a 4 squared and 3 squared, we're left with 1, 2, 3, 4, 5, 6, 7 tiles. So 16 subtract 9 equals 7. And that's 7 tiles. Now let's do another one. And 5 by 4. Oh, this one's 6 by 5. So 6 by 5 would leave us with 11. So 36 minus 25 equals 11. So all three of those gave us some sort of pattern. 5, 7, and 11 are all odd numbers. They're also all prime numbers. So you could say your conjecture would be that they are prime numbers. You could say that your conjecture is consecutive. The difference between consecutive squares is always odd. Your conjecture could be that they are always prime numbers. Those are conjectures that you can make from the 3 examples that we've done. To do the same question using numbers instead of shapes, all we have to do is we have a 2 by 2 square and a 1 by 1 square. 4 subtract 1 is 3. And if we had a 4 by 4 square, 3 squared, do the subtraction, you get 7. And here's a bigger number, 9 squared minus 8 squared, 81 subtract 64 is 17. So again, all three of those numbers, 3, 7, and 17, are all odd numbers. They are also all prime. So we can make a conjecture that the difference between consecutive perfect squares is always a prime number. Or we could say the conjecture is that the difference between consecutive perfect squares is always odd. Those are possible conjectures we can make given the numbers that we used.